In this video, I'm going to focus on financial math again, but in particular to do with present value. So we're going to basically try to identify what the present worth of a future amount of money is. So for example, let's say you wanted €20,000 in 5 years' time and the bank were offering a savings rate of 5%. You wanted to know what did you need to put into the bank now to achieve that target. That's what you'd use present value for. So the formula is in the tables, as I've just highlighted there, and it states that the present value is just equal to the future value over 1 plus I to the power of t. So it's found from the compound interest formula. If you divide both sides by 1 plus I to the power of t, then you can just work out what the principal is, or the present value. Alright, so in these questions we're looking for the present value of a future amount of money. So what's the present value of, let's say, a future amount of €20,000, which has been in the bank, let's say, for 5 years, so time is equal to 5. Let's say the interest rate is 4%. Okay, to work that out, we're just going to plug in our numbers into the formula. So the future value is €20,000. Our interest rate is 4%, which is 4 over 100. 1 plus 4 over 100 is 1.04. And the time is 5 years. So that would make our present value equal to 16,438 euro or sterling or whatever denomination you were asked in the question. Right, so it's a really important concept, used quite a bit for even pensions. If someone wants to get an annual payout of a certain amount of money, well, they want to know what is the current value of that amount of money. Now we're going to be using this question with geometric series, just like the last video, to work out what the present value of money is. So now I'm going to focus on a past paper question. These leave answer questions from 2015, paper 1, question 6. Before we get to the present value amount, we first are asked to calculate an annual percentage rate, so an annual rate from a monthly rate of 0.35%. So the question states that Donna is arranging a loan and is examining 2 different payment options. Bank A will charge them a monthly interest rate of 0.35%. Find corrected 3 significant figures, the annual percentage rate. Okay, so here we're looking for an annual rate. So we're going to use this formula, where our final amount is equal to present times 1 plus I to the power of t. Well, we're looking for the final amount, and we know that the monthly interest rate is 0.35%. So therefore, the final amount will be equal to, well, we just keep our principal as 1, our interest rate, which is 1.0035 to the power of t. Well, as that's a monthly interest rate, we're going to multiply it by the power of 12, and that gives us a figure of 1.042818. So our interest rate then is going to be 0.042818. Alright, so that's going to be equal to 4.28%. The next question basically says that Bank B will charge them a rate that's equivalent to an APR of 4.5%. So what that means is it says find the monthly interest rate that 4.5% generates. So in this instance, we're again using the formula F is equal to P, it's out of 1 plus I to the power of T. Except that here we're told that the annual rate is 4.5%, so 1.045, which is our annual rate, is going to be our monthly rate to the power of 12. So we take the 12 through both sides, just like we did in the last question. So our interest rate per month is going to be 1.045 to the power of 1/12 minus 1. And that gives me an answer of 0.00367, which is 0.367%. So in both those questions, we've gone from working out a yearly interest rate from a monthly rate and then working out a monthly rate from a yearly amount. So this would be in part A of that question, this is part B. Okay, so I'm just going to move this stuff to the side because now we're focusing on the real present value question, which I wanted to initially. So we have all the information there. We told that Dunne borrowed €80,000 at a monthly interest rate of 0.35%, fixed for the term of the loan. The loan is to be repaid in equal monthly repayment amounts over 10 years. The first repayment is due 1 month after the loan is issued. Calculate, correct in the nearest euro, the amount of each monthly repayment. So we're told that the repayment is a constant amount. Basically, the present value of future payments is going to be given by this formula. Present value is equal to the future payment over 1 plus I to the power of 1, okay, for the first month, plus the second payment, which has been there for 2 months now, and plus all the way to the end time, which is 120 months. So we need to work out what that future payment is going to be. We know that the present value, the loan is 80,000. So 80,000 was our loan. So that's going to be equal to whatever the future value is over the interest rate, which is 0.35%. So it's 1.0035 to the power of 1 plus f over 1.0035 to the power of 2, all the way up to 1.0035 to the power of 120. Now, what you could do, instead of using f there, we could just call this the repayment amount A, which I'm going to do in another video when we talk about the amortisation formula. Alright, but hopefully what you see is if I factorize f out of all of these, what I've got is a geometric series. So, if I've got to factorize f, I've got f outside of 1 over 1.0035 to the 1 plus all the way up to 1 outside of 1.0035 to the power of 120. And using the sum of a geometric series, so which is a, the first term, outside of or to the n minus 1 over or minus 1. Okay, you can use a outside of 1 minus or to the power of n all over 1 minus or, but that doesn't make a difference. We still get the same answer. So we just identify a, we identify or, and we identify n. So a in this instance is going to be our first term of that geometric series, because remember this part is a geometric series. That means that you start with one term and each successive term is multiplied by a common ratio. So a, which is or, a in this instance is the first term, 1 over 1.0035, or is going to be our term 2 divided by term 1, which is going to be 1 over 1.0035, and n in this instance is the time, which is 120 months. So n is equal to 120. If I basically put this in here, I have f outside of 1 over 1.0035, all outside of 1 over 1.0035 to the power of 120 minus 1 all over 1 outside of 1.0035 minus 1. So just to tidy this up a little bit, our 80,000 was equal to this. So if I cross multiply here, I'm left with final amount, which I could have called f or called a, is going to be equal to 80,000 divided by all of this, and that figure, just if you put it into the calculator, that figure works out as 817.58 to the nearest euro. That's 818 euro. Okay, so all I did there was try to find out what the future payment was going to be every month, okay? And I used the present value of the loan being 80,000, and I found that as the payment is going to be a consistent amount every month, it's going to increase by a consistent amount. It forms a geometric series because I'm adding those terms together, and therefore I can use the sum of a geometric series formula, which is here, to work out the repayment amount. Now I'm going to show you how that formula leads directly to the amortisation formula, which is a formula that's used to calculate repayment amounts So instead of saying F here, we say A. It's a formula for calculating repayment amounts instead of going through the whole geometric series. But I'll show you how it's linked in another video. The amortization formula is here, where you can calculate a repayment amount. Okay, so if I just plug that into the amortization formula, I will get a repayment amount of 818, and I'll just show you that now. So just to restate, that is going to be our repayment amount. I'm just going to call the repayment amount A. Okay, it's the same as here. I called it F, but I could have called it A. That's going to be equal to the present value, which is our 80,000, outside of the interest rate times 1 plus the interest rate to the power of t, all over 1 plus the interest rate to the power of t minus 1. If I plug that in, I should get A is going to be equal to 80,000 outside of interest rate, which is 0.035, times 1 plus the interest rate, which is 1.0035, all to the power of 120, which is my 120 months, all over 1.0035 to the power of 120 minus 1. Alright, and that gives me a repayment amount of 818 as well. So that is called the amortization formula. Okay, and the amortization formula is really useful for calculating out loan repayments and things like that. And it's in the table, so that's fine.